So I wanted to say a little more about construction and interpretation of the t-test in regression. So the basic construction and interpretation of the t-test follows from the example in the last lecture, but this time you have n minus p degrees of freedom, where p is the number of variables in the regression model. So as before, t is the estimate minus the hypothesized value over the estimated standard error, and then because it's extremely common to test this hypothesis that the hypothesized value is equal to 0, then the usual formula, the t-statistic, becomes estimate minus 0 over the estimated standard error. So if you get the Wodgev computer-generated results from either R or eViews or any other software package you care to mention, what you will typically often see is a whole host of t-statistics calculated as precisely the estimate over the estimated standard error. Okay, there's other hypotheses that you can test, but it's just that empirical experience is that it makes sense to set up the computer program in such a way that you automatically test this null hypothesis that the actual parameter in question is equal to 0. And then, as we will see in this lecture, this has the interpretation of testing the null hypothesis that there is a 0 flat correlation. So the t-statistic that R and E use another software then, so you can construct this as being the estimate minus 0 estimated standard error. So in this example, you put this thing here. So the estimate is minus 0.0646, estimated standard error 5, and you answer here minus 4.502. To sort of really read this, if you take the absolute value, so the absolute value minus 4.502 is just positive 4.502. This is bigger than 2, so there's an indication, because this is bigger than 2, that there is a sizable effect here. So R calculates the p-value to be times 10 to the minus 5. The idea would be that whilst we can't calculate its p-value exactly by hand, you could produce a bound for it using tables. Now, true, that's probably limited importance really in COVID because I can't set you a written exam, okay, but usually you would do a hand to the calculation using tables. Say here is that the numerical calculation by a computer is more accurate than using tables, and this increased accuracy does hint at how worthwhile computers are. So I wanted to sort of try and go through here and reconstruct what exactly R is doing. Now, in years when there isn't a global pandemic, I would usually set something a little bit like this on the written exam. Now, because of COVID, there's no exams, it's just coursework, so it's not so directly relevant for the assessment for the module, but it's still, I think it's useful to sort of just work through what's going on and give you the equivalent hand calculation. So R calculates the p-value minus 5. Now here, if you're going to do this, n is 33, p is the number of variables in the model, which would be 2, so the degrees of freedom would be 31. We then need this value in tables, which would be 4, and how you would do this would be the t value, so once you do the absolute value of this would be 502 from tables, and if you do this correctly, inequality signs point the different way, so p is less than 0.05. Tell you some evidence p less than 0.05 is as the coefficient is negative, and as we've just seen, increase. Now, alongside the t-test, there's this f-test. So the t-test tests for the significance of individual parameters, and the idea of the f-test is that you can test the significance of multiple parameters simultaneously, and on the sort of pie statistics and general bookkeeping, the idea is you want some systematic way of testing the overall fit of the model. Okay, and the systematic bit here is the important bit. So it's possible to perform a sequence of t-tests in order to sort of do this and test the overall fit, although for statistical reasons this isn't really desirable. Now the problem here is something called multiple testing. So if you've done some statistics before and you're comfortable with this, the reason the t-test won't work in this way is something called multiple testing. If you haven't done much statistics before, don't worry about it. It's just that the real reason why you have to do an f-test here, not a sequence of t-tests. So the f-test performed automatically by either E or R is only one possibility amongst many different ones and might have only limited value in itself. It is intended, however, to create material in the next lecture, which will try and show that these f-tests and the extra sum of squares principle can be applied much more generally. So what happens when you fit regression models in E or R? The software produces an f-test that tests the overall fit of the model. Now that might sound pompous. The question it's really asking though is this: is one of the x variables in the model have a statistically significant effect on y? So it's not always written down like this, but in terms of formal hypothesis testing, what you have is this multiple linear regression model. The hypothesis in this case is that none of these x variables actually have a correlation with y, and the alternative hypothesis is at least one of these betas is non-zero, so at least one of these x variables has an effect upon. You don't necessarily know which one, but you know there's at least something there. You don't know exactly what. It's just there is at least one x variable that has some sort of relationship with y, and then if this is the general case for the multiple linear regression model, for the two variable regression model, you get a simple situation and just a repetition of the t-test. So in this case, if you only got one x variable, you're necessarily testing the null hypothesis that there's no relationship to the relationship between y and x2. So wanted to sort of revisit this two variable regression model. So the output statistic is 7 and 1, 31 degrees of freedom. The matches again p-value calculated from the t-statistic for this simple two variable regression model. So just to reiterate then, so this would best be interpreted as, and the p-value in this case, but 0.005, that the real stock price affects the real gold price. We'll see in the next lecture, and we saw on the previous slide that the interpretation of this f statistic changes slightly when you've got more than one x variable in the regression model in addition to the constant term. Okay, so what you're doing here is producing the f statistic to test the joint significance of all the x variables in the model. If there's only one x variable in the model, then necessarily you get a repetition of the individual t-test, but if you've got more than one x variable in the model, then you get something that's different and richer. Okay, and we'll talk a little bit more about that in the example later in the lecture, but we'll go over this more fully in next week's lecture. So I wanted to try and show where the numbers produced by either eViews or R come from. Now I've said there in the slide, give you some additional practice using the F tables. Really that's not so important this year. That's only important in years when there isn't a global pandemic and students do sit a formal written exam at the end. So in terms of the general multiple linear regression model, you want to test the null hypothesis that 2 equals beta 3 equals all the way up to beta p equals 0. The alternative hypothesis that at least one of these betas is non-zero. Equivalently, this just means that you're assuming in the first instance that none of the x variables have a correlation with y, and then the alternative hypothesis is that at least one of these variables has a relationship with y. The way you construct the f statistic is as follows. It can be calculated as the difference in the sum of squares, the residual sum of squares for the big model. So this is just going to be r squared times the total sum of squares. Difference in degrees of freedom. So there are p minus 1 here when the all is 0. So this has to be p minus 1 on the bottom. Residual sum of squares 1 minus r squared times the total sum of squares, and you have n minus p residual degrees of freedom. And the f statistic can be written just in terms of the r statistic. So our output says that the multiple r squared is 953. So the idea is you could construct the f statistic as those. Then here is manipulation of the fraction is exactly the same as multiplying by the reciprocal of the fraction. So plug the numbers here and we get 7, and then you would need to compare this value from the tables, and you would have to interpolate, giving you the calculation there, though you don't necessarily pay too much attention to this. Something you need to pass your formal written exam. So the idea is that the f statistic 20.267 is greater than the value from tables, which is 4.161. So P is less than 0.75, so that these things, and you've got evidence here that the real stock price affects the real gold price. Okay. The idea that the F statistic can be written in terms of the statistic is something we will go through in more detail in the next lecture. So I wanted to give you a multiple linear regression example, okay, and just to sort of show you how this thing works once you've got more than one x variable. So in this instance, this F statistic would be testing does at least one of these x variables affect the y variable in question. So this the famous Longley dataset, sufficiently famous to be given its own name, and the idea is that you want to explain the number, the gross national product, the number of unemployed, the unemployment rate, the non-institutionalised population over the age of 14, so people with sufficient good mental health to be deemed eligible for work, and x6, the yearly time trend. And the basic idea then, I wanted to sort of show you how you run the regressions, essentially the same as before, and then these three things in terms of the interpretation: the R squared statistic, the T statistics measuring individual significance, and then the F statistic to measure the overall fit of the model. So again, the overall fit of the model, in this case, you're testing the hypothesis that at least one of these x variables has a tangible effect on the number of employed people in the US. So these things are designed to make sense with real data examples. The data is available in this file longley.txt, available from the module page on Canvas. So the best way to do this is to save this text file onto your USB stick. On my computer, my USB drive was drive E, so you need this command here, read.table applied to this file path. If you see what is different, you might need to change this letter here. And how this works is the same rhythm as before with all these examples. The first column of this data set, x3 goes to the second, x4 to the third, x5 to the fourth, 6 will be the fifth column, and y will be the sixth column. And just to sort of reiterate here, it does work best if you name these logically. The name you call it in the first line has to match the name you call it x2, x3, x4, all the way down to y slide. Okay, you've got some freedom in terms of the names you call these things, but you must make sure that the names all match each other, otherwise the computer will get confused.